Polymerization. Polymerization is the process of mixing of large number of small monomers to make one single huge molecule. So that molecule is called polymer. Polymerization is the process of making up the large molecule from the small molecule by different mechanism. I mean, one is called addition polymerization, and other one is said to be, you are very much familiar with this one, condensation. Condensation polymerization and addition polymerization. There are two types of polymerization. Addition, as the name indicates, that is the property of the alkenes to be added up, and that's why it is called addition polymerization. So whenever different small molecule of alkenes are added together to make a large molecule that is having almost uncountable units, then that molecule is said to be polymer. So monomers monomers make one polymer. Polymer monomers. Many monomers make one single large molecule that is said to be are known as polymer. At the moment, I'm going to revise addition polymerization that you have been studied in your O-level chemistry as well, in AS chemistry as well, and so on. So addition polymerization, for example, I'm going to take the smallest alkene in this universe, that is ethene. I mean one ethene, for example, just for the sake of example, second ethene, and here are some different conditions. Number one, catalyst is used, that is Ziegler-Natta catalyst. Ziegler, I think you are not bound to memorize this name. However, pressure around about 200 atm, and traces of oxygen, that is essential to initiate the side chain reaction. The effect of, or the importance of, or the participation of the oxygen was not in your previous syllabus. I am going to tell you now that in this mechanism, traces, very minute quantity of the oxygen is also added to link the different chain through its side chains. So side chain linkages are, I mean, to develop the side chain linkages, it is necessary to add some low amount of oxygen. And finally, heat, almost 200 degrees Celsius. So these are the basic condition. In a container, there is a container which is having different or the similar or the same type of alkenes, carbon-carbon double bond compound. Then we are going to add or introduce Ziegler-Natta catalyst. We are going to apply the pressure of 200 atm, and we are also going to add traces or the very few amount of volume of oxygen, and we are going to heat the whole system at around 200 degrees Celsius. What will happen? What is the basic mechanism? Just have a look. There is a shifting of carbon-carbon double bond. Multiple bonds are shifted basically. I mean, this one molecule, once again, similar type of molecule is over here of the same type. This bond will be shifted over here. At the same time, this bond will be shifted over here. This is the simplest, very simplest way out mechanism, method, how different addition polymers are formed. So that is over here. See, single bond is remaining over here. H, and H, previous hydrogen atoms. This is the new bond formed. And again, there is a new molecule with H, H, H. One bond over here at the end, one bond that is placed initially over here. So this is the part of the polymer, and we called it poly. What is the name of its monomer? The monomer is
ethene.
ethene. Good. So its name will be polyethene. Although there is no any double bond in the molecule, but you will write ethene. The name is the indication of the process of polymerization of monomers. This molecule have been made by the combination of different ethenes. I mean, all type of ethenes. So this is the polymerization of ethene. So it's called simply. This is one of the simple way. Here we write its name that is said to be polyethene. Now the next thing, I'm going to take another alkene that is, the sample of alkene in which once again, all molecules are pretty similar. So let's see over here. For example, I'm taking this one alkene this time. So all type of molecule inside the container, inside the box are, I mean, like this. They are this molecule. What is the name of this molecule? Let me copy and paste. What is the name of this molecule? Please let me know. What is the name of this molecule?
But but
Um,
but
Wrong.
but क्या
Wrong.
but but
Carbon number one, carbon number two, carbon number three, carbon number four. This is the position of one double bond. This is the position of second double bond. So there is no branch. Whole carbons are four carbons are there, but there are carbon double bond, but they are,
but
and
one
even
three
they are in two number. So one, three, and they are in two number. So you will write di and you will write ene. But 1,3-diene is the name of this compound. You
same
forget
thing,
your
sir.
AS chemistry as well.
Same thing,
Now
same
there
thing.
is another thing that you will change this molecule. I mean, the format of the molecule will be changed, not the formula. Format of the molecule will be changed while designing, writing, reporting your answer. How? I am going to rewrite this molecule: carbon carbon double bonds, carbon single bond, carbon double bond, and carbon over here. Here are two hydrogens. One I am going to place above and one below. There is no change in chemistry. There is no change in formula. I'm just changing the position of different atoms or group of atom attached to these carbon. So let's suppose I'm writing here this hydrogen, same as the case, this hydrogen, and two hydrogen, one above and one below than this carbon. Now I'm going to make it copy and paste for the, ease of my own. Copy, and here I'm going to paste it. So there it is. And one more molecule I want to paste it over here. Yes. So this is the accurate format before you are going to draw the picture of polymer. So write your monomers like that. Number one. Number two, shifting of double bond. Now, how to shift the double bond? That is very, very important, especially in A2 chemistry syllabus. This double bond will be shifted over here, not with other molecule. It will be shifted over here on the very next single bond. If there is any other next single bond, carbon carbon single bond is present, or you can say this carbon carbon single bond is sandwiched between two carbon carbon double bond. So under all these conditions, if double single, I mean alternative double bonds are present, or the single bond is in between two double bond, then this, please note it down. This is the true and actual mechanism to make your polymer. So double bond will be shifted over here at the same time, or in the next step, this double bond will be shifted over here between two molecules. At the same time, after the shifting or while it's shifting with this molecule, this bond will be shifted on the next slot, carbon carbon single bond, and this will be shifted over here once again. This will be shifted on the next slot, and double bond will be shifted further with any other molecule. One more thing you will have to keep in your mind: carbon carbon double bond will be shifted before another carbon that is doubly bonded carbon. I'm going to repeat once again. A carbon carbon double bond is shifted with other carbon, with that carbon that is doubly bonded carbon. Just have a look. This carbon carbon double bond is shifting over here because this carbon is double bond carbon. This carbon carbon double bond is shifting above, or I mean beyond this molecule to the next molecule with carbon, with this carbon, because it is a doubly bonded carbon. So yes, it may attack over here, it may be attached with this carbon, but whenever the bond is, once the pi bond, the double bond is broken, and it is allowed to shift with another molecule, the bond will be shifted with that carbon that is doubly bonded carbon, not with a single carbon, not with a single bonded carbon. So this is the basic mechanism. I'm going to rewrite what has happened over here, and it's better to copy and paste once again. So I joined basically three molecules, monomers at the moment for the sake of example, and here they are. So how to write and what to write? Basically, here is no more double bond. This bond has been shifted, and where it has been shifted over here, then this bond has been shifted where, over here, this one over here, and this one. It's easy, it's a child play. I mean, it's not a big deal for you, especially man. And double bond over here, and this will be cancelled out, and it will be shifted over here. One bond over here, one bond must be from the starting point over here. There is I mean an essential point, an essential step to write these two bonds before and after the chain. Now, this is a unique type of polymer. Obviously, its name will be poly 1,3-butadiene, and this polymer is having yet double bond in it. Yeah, this may be. So, this is the polymer, but it is yet having carbon carbon double bond. So there may be the further complex chemistry of this molecule. These double bond may be shifted with its own neighboring chain, like that. For example, for example, I'm having, and I'm copying, paste it over here. For example, so there will be the mutual shifting of bonds between these carbon. This bond may be broken, it may be shifted over here. This bond may be broken and shifting on the next line. So in this way, yes, in second round, you can develop the side chain linkages between all these chains. And it is going to be more rigid polymer, hard polymer, because it is going to have more cross linkages. Number one. Number two, we have added, as I told you, traces of oxygen in this mixture. So basically, what the oxygen is doing over here, oxygen is basically making radicals. That is not very much simple to explain, but this thing you must keep in your mind. Oxygen is going to make O double bond O is going to broken down, and it is going to make oxygen radicals, right? So oxygen radicals, O radical it may be, or it may be, I mean, O2 radicals. So these oxygen radical then hit with these carbon. Those are having hydrogen, and they are going to substitute the hydrogen. They are removing these hydrogen. And again, because of the radical, when there is termination, cross linkages is going to be formed. So generally speaking, it's a very complex topic. It's a complex subject. It's not a topic, it's a subject. I mean, there is much more, many more library, or the libraries over here, those are having just polymer chemistry, and people simply they do PhD in polymerization. There is a huge field of chemistry, in my opinion, and in the now in the this new era, especially when we are very much used to use the polymers like uh, plastic rope, plastic chairs and tables, and many more things that is made up of plastic. I mean, we have replaced the iron articles or iron objects. So this is I'm not going deep into detail of this topic. I'm just letting you know that is the necessary, or slightly more than that, of the necessary things about your syllabus. So number one, you should be able to draw the longest chain, normal simple chain. Number two, don't hesitate, or don't be surprised if there is a yet double bond present in the longest chain, in the polymeric chain. Yet it may be, this is the first step that you will be asked in your answer. But yes, on the next step, uh, as you have mentioned, and you will have to mention the traces of oxygen over here. In next step, there are two type of further polymers, right? So I am talking about the simple polyethylene. For example, once again, polyethylene, simplest, smallest monomeric polymer. Smallest monomer is ethene, and its polymer is called polyethylene. Here is the structure, that is, one is said to be HDP, and other one is said to be LDP. I showed you over here. This is the polyethylene. This one. This is the polyethylene. Very simple addition polymer, right? And furthermore, because of oxygen, it is going to make its side chain linkages. It's making cross linkages. We call it cross linkages, side chain linkages. And because of that, on the behalf of type of linkages, on the behalf of type of structure, one is said to be HDP, and other one is said to be LDP, high density polyethylene, low density polyethylene. Now, you know what the density is. Density is equal to mass per unit volume. High density mean is the volume is higher because mass is same. In addition polymerization, there is no loss in mass. In addition polymerization, there is no loss in mass. The same, the mass of the reactant is equal to, or is the same as that of the mass of the product. There is nothing is lost. It's not condensation, it's addition. So mass is pretty similar. Then why we call them sometime high density, sometime low density? What is the reason behind it? What do you
Different
mean by the
arrangements
density?
and side chain.
Mass over volume, yes. Because of the side chain, volume is going to change per mass. Let's suppose I have made 1000 gram polymer, but one is HDP 1000 gram, other one is LDP 1000 gram. Both are having same quantities, but again they can be described, they can be distinguished, HDP and LDP. The basic reason is, if the volume is less, right? then it is called high density lipid. If the volume is low, basically, this denominator factor is low, relatively, it is called high density polythene. And if the volume is high, denominator is going to increase, overall density is going to decrease, so it will be known as low density lipid. In low density, there are basically more branches and especially irregular branches. Irregular branches, branches, gaps, and so on. So irregular branches. I think you cannot see me. Can you see me? I mean,
I
Yes,
can see
yes.
you.
okay. Irregular branches, basically, and here are regular branches. The basic difference is volume and packing and regularity, right? Regular, irregular branches. So the basic difference, packing, proper packed or closely packed, right? Basic factor is the volume. If the volume is going to decrease by regular arrangement, by close packing, then it will be high density lipid. And high density mean it is rigid, it's a hard, right? And low density, irregular shape of the branches, irregular packing, loose packing, not closely packed, not closely packed, and so on. And so they are relatively soft, like shopping bag, if I'm not wrong. So the example, they are in low strength and like cling films, like shopping bags. Yes, yes. Shopping bags, like for example. And this one is the hard plastic bowl or plastic bottle. And yes, I think plastic bowls, plastic, hard plastic chairs, वगैरह वगैरह वगैरह. I mean, so basically, they will ask to draw the structure. They will ask to check which one is the, I mean, HDP, and which one is the low density. So HDP, for furthermore, HTP, high density lipid, is having less number of branches, or its structure is, uh, less scattered, less irregular. That I basically want to say. But in low density lipid, if I'm going to draw the general structure, and it is more irregular, and I mean more D shaped, more irregular shape. That's why they are going to change their volume. So basically, the last one, in my opinion, in my memory, that is PVC, polyvinyl chloride. If the different monomers are combined together, one is, once again, this is called, uh, not, I mean, once again, this is propene. This is propene. I'm writing CH3 above, H below, C, H over here, 1H over here. Propene plus I'm going to write chloropropene, chloroethane, I'm sorry, chloroethane. So this is called, basically, its common name is vinyl chloride. So these two can meet together. Just vinyl chloride meet together with themselves. I mean, with the same. If I'm going to add them out, just these same type of linkages, if same type of monomers are going to meet together, they will make PVC. PVC. Here, I mean, it's not good to write PVC over here. Here are, these are the two different. If I'm going to add these two different molecules, then different structure with different arrangement of the monomer is possible. But when these two, as I have, I mean, explained over here, that if I'm going to mix two ethene, so R2 propene, R2 same 1,3 butadiene. So our but 1,3 diene. So there were the same structure. There were only one type of molecule, one type of structure, one type of structure, and so on. But if you are going to mix two different alkenes, right, then obviously there will be the different arrangement of the monomers. Arrangement of the monomer will not be the specific. Two same, let's suppose it's A, let's suppose it's B, two same AA can meet together because both are having double bond. Then there may be the possibility that A and B meet together to make AB structure. Yes, it is possible, and so on. But whenever you are going to mix both vinyl chloride, then same type of molecule is formed. Obviously arrangement will be the same because the both monomers are same, and here I'm going to write it. But there are the two pattern. How, what does that mean? Number one, I'm writing this molecule like that: C double bond C, Cl, H, H, H. Similarly, the second one is Cl, H, double bond, H, and so on. Here I'm putting one bond, here one bond, and now I'm erasing one bond. This is this one of the possible pattern of PVC. This is one of the possible pattern of the PVC. It's a polymeric chain, it's moving, and so on. Now the next thing is, what is the different pattern? The second pattern, I'm going to write it with the red pen. That will be like that. Cl over here, H, double bond, H, H. But this time, I'm going to reverse this molecule. I'm going to rewrite this molecule in different way. Here it is. Now, initially there were one Cl, then hydrogen, then one Cl, one hydrogen, Cl hydrogen, Cl hydrogen. But this pattern is not going to be followed anymore in this case, especially when this bond is shifted over here. This will be over here, one bond here, and remaining we are having this polymeric chain. So this is the pattern is different. Formula is not different overall. Name is not different. It's a PVC, but the pattern is different. Now, two hydrogens are at adjacent position and throughout the chain. The second pattern in the same chain, it may be, I'm going to draw it with the white pen. That may be a green pen. Okay, by chance, I take it. Is hydrogen, it's Cl, here is initially double bond and carbon Cl H double bond CHHC. I'm shifting this double bond over here, this over here, and removing these double bonds. So this is again, it is same that is said to be PVC. So you can say there are basically at least three, not two. There are three patterns. One pattern, Cl and H are at alternative position. Second pattern, two hydrogen are at adjacent positions. Here, two Cls are at adjacent position. So basically, there are three different patterns, but all are said to be polyvinyl chloride. Next and the last thing about the polymerization, polymerization may be asked in cyclic compound. For example, this is a cyclic compound and its name is cyclohexene. Its name is cyclohexene. So one cyclohexene can be mixed with other cyclohexene? Yes, of course, because it is having double bond and this double bond can be shifted. So what is the basic mechanism? That is the pretty similar, and it will be like that. Different monomers can be made. Yes, it is true. And how to make it? I am going to draw another similar cyclohexene over here. And I'm writing double bond over here. Are they two same? Are these both are cyclohexene?
Yes.
Yes.
Yes, exactly. I just wrote it in another way. So similarly, I can write an other cyclohexene like that, hexene like that. again a cyclohexene like that. So I'm shifting. It's a magic. So one bond will be shifting over here. This bond may be shifting with this double bond carbon. Once the bond is broken, it will be shifted with another doubly bonded carbon. We cannot shift this bond over here, 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 or here. No, because there are no carbon-carbon double bond. This bond will be broken and it will be shifted towards either with this carbon or with this carbon. Okay, one and same thing. And same is the case, it will be broken over here and it will be shifted over here. Now the valency is satisfied. I mean, overall shifting is completed, and this is the small, it's not a polymer. I mean, it's a tetramer. Just 4 units are together. It's type of polymer. It's not a polymer. Like there is dimer. Similarly, it is tetramer. So in this structure, this can be written as like that. I mean, once again, you can see that one hexene or hexene, there is another hexene or hexene, there is another hexane or hexene, and there is an other hexene. If I'm not wrong, 1, 2, 3, 4, 5, 6. 4 and plus 4 8, no sorry, here are basically 4, then there will be more than that of 4, not basically just a minute. If I'm going to make this one, for example, this is another question you can say, this is another thing you can say, and is this can be made from any polymeric structure, I mean any monomer. If this is the trimer, it's not tetramer basically, it's a trimer. Can you make it from this sort of alkene? Yes. If only three rings are get together and they are shifting their double bond, and then yes, this molecule, this one can be formed. But this molecule here are basically an octagon, you can say. 1 2 3 4 5 6 7 8. Yes, in between four as hexagon there is an octagon, and this one is this structure that is very much confusing structure. Basically it seems that there are four hexagon, but no, there are not four hexagon. Basically these three bonds are the shifted bond, and this is called a trimer. So you can add two molecules, three molecules, four monomers, five monomers, and many monomers to make a polymer. So similar question hopefully will be asked. And as far as my opinion is concerned, it's not a very much difficult topic. You can ask any question if you are still stuck.